Today we're going to be writing linear functions from tables. So when we're looking at this worksheet 2.4, writing linear function from tables, we're going to use the following tables to represent linear functions, and then you're going to write the function rule for each. And then you're going to take, once you write the function rule, you're going to use the functions that you got from 1, 2, 3, and 4 to answer the following problems right here, to solve those. Now, I've already completed the first one for you, so I already know that this is a linear function, and when we're looking at linear functions to solve them, we have 3 steps. The first thing we have to do is find the slope, then we're going to find the y-intercept, and then we're going to write it as a function. So, I have already worked these out. So the first thing that I am working on is to find the slope right here. You're going to use the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then we're going to turn around, and once we find the slope, we're going to put it in the slope-intercept form right here. So I'm going to start at the bottom, and I'm going to go backwards. And I'm going to look at this 0.52. So I'll put my y on top, 2 over 5. Then for 1, I'll put my 1 over on top, 4 on the bottom, because you want your y's on top. And then I can put all of this at one time into the graphing calculator. So when I put this all at one time into the graphing calculators, I can go to alpha y equals, hit enter, 2 minus 1 over 5 minus 4. And you see that we have the slope of 1. Now, I'm going to take this slope of 1 and I'm going to put it in the slope-intercept form. I'm going to pick a set of points. It does not matter which set of points you use. And I'm going to use 5 and 2 right here. So when I substitute out the y, m, and x, my y is a 2, my m is 1, and my slope is 5. When I solve it, I get b is a negative 3, which is your slope-intercept form, which is the y-intercept. Now, I'm going to take this right here and put this in slope-intercept form, which is y equals 1x minus 3, because my slope is 1, my y-intercept is 3 right here. So I'm going to write it in a function form. I'm going to put f of x equals 1x minus 3, or you can put f of x equals x minus 3. And then once I have that written in slope-intercept form, or function form, I'm going to take this and bring it up here, and I'm going to find where 10 is, what 10 represents. So we want to substitute 10 in place of this function form right here at the bottom. I come up with 1 times 10 is 10 minus 3, and that gives you 7. Now, if you were to write this as a point, it would look like this, 10 and 7. Now, this way, look at this one right here, f of x equals 32. Right here, you see f of 10. This time it says, well, f of x will equal 32. So in other words, I've got to take this right here, which is in function form right here, 1x minus 3, or x minus 3, and I have to see what is my x, because I know all of this right here has to equal to 32. So when I write it out, solve it just like you do in an equation, your x is 35. So now when I write it as an ordered pair, it'd be 35 and 32. I can go back and very easily check to see if I have if this right here, if this 1x minus 3, and you can put it as x minus 3 or 1x minus 3. I can go back and check my table, go to second and graph, and I'm going to check these points right here and see if this is the correct function for this. So I see I have a negative 3, negative 6, matches up. Negative 1, negative 4, matches. 2, negative 1, 2, negative 1 matches. And then I have 5, 2 matches. Now I'm going to go over here to 10 and 7. So I'm going to see, go down here to 10, and then I see that it does match. Now I can go all the way to 35. And when I go all the way to 35, I see that 35 is 32, the same thing. So I definitely know that this right here is the correct function for this table. Now, when I'm looking at linear functions for it to be a linear function, it has to have the same slope in the right here, which is the same common difference. Now, here's what I want you to do. I want you to take problem number 2, and I want you to work it just like we did problem number 1. So the first step, remember, find the slope, then find the y-intercept. Write it as a function. So this is what I just did. So in problem number 2, you're going to work it out just problem number 2. You're going to work it out just like what we did in problem number 1. Now, put me on pause and work problem number 2, just like problem number 1 is. Now, look at problem number 2. Check yours to see if it matches. So the first thing I did was I found the slope. My slope is 1. I used these 2 sets of points. It does not matter which 2 sets of points you use. I do know that this is a linear function, so it doesn't matter which set of points I use. Now, I used 7 and 12 right here and my slope to put it in slope-intercept form. So my y is 12, my m is 1, which is my slope, and my x is 7. And when I solve it, I come out with my y-intercept, which is your b, is 5. Then I write it as a linear function. So when I write it in function form right here, I see that I have f of x equals 1x plus 5, which is the same thing as saying f of x equals x plus 5. Now, I'm going to substitute this in, put 20 in place of the x right here. And when I do and put all of this at one time in the calculator, I come up with 25. If I were to write this as an order pair, it would look like 20, 25. Now this one, see how this is written? This is written different from this. This says f of x equals this. So my x right here is 20. That's why I substituted in. Now this one says, well, all of this right here has to equal 45. And when I put it in, when I put x plus 5 equals 45 and solve it, then I come out with x equals to 40. So now if I write it as an order pair, I would have 40 and 45. I can very quickly and easily check to see if this is correct. So I can go back to y equals, I can substitute in x plus 5. I can go to second and graph, and I can check each one of these points out right here. All the way, you see -1 and 4, 2 and 7, 4 is 9, and you can just keep on going and check them all out. 6 and 7 both matches this. So I know this is correct. Now I want you to go and work number 3, just like what you did on number 2. Make sure that you find the slope first, find the slope, find the y-intercept, and then put it in function form. So I'm going to move back to number 2 so you can use that as a guidance. So work number 3 just like you did number 2 right here. Now put me on pause while you work number 3. Now let's look at problem number 3. The first thing you had to do was found the slope. It does not matter which 2 sets of points you use. I use 0, 0, and 1 and -4. So when I did, I came out with a slope of a -4. So I'm going to take this right here, and I'm going to use 0, 0 because I want to use the smallest numbers, and I want to see if I can use all positive numbers. And I definitely want to use anything with 0 because I know that anything times 0 is 0. So I'm going to use the point 0, 0, my slope is a -4. Substitute in the slope-intercept form, y equals mx plus b. Substitute out the y, m and x. So here's my y, there's my x. When you multiply it out, your b, your y-intercept, is 0. So now, when I look at this right here and I write it as a function, right here in function rule or function form, I see that I have f x equals -4x plus 0. And you don't have to put the plus 0. You can just write it as a -4x. Now, when I come over here and substitute out the x for 12, and I put the 12 in place of the x, I see that f of 12 does equal to -48. If I were to write it as an order pair, it's going to look like this, 12, -48. Now, I see that all of this right here has to equal to a negative 36, and we're going to solve it. So I'm just solve it just like I would at any equation. So I'm going to, the inverse of multiplication is to undo, multiplication is division. So when I divide by -4, my x is 9. Right as an order pair, you have 9 and a negative 36. Now, I want you to work number 4, just like what we did for this one right here. So you see that you have number 4. Now, work it just like you did number 3. Pause me while you do so. Now, when you're looking at number 4, check to see if your number 4 matches mine. Your slope right here is 9, and like I said, it does not matter which set of points that you use right here. So when I look at this right here, my slope is 9. I use these 2 sets of points, and I use the 1 and 8 to substitute in right here when we put in slope-intercept form. So when I substitute out, the y right here is 8, the m is 9, the x is 1. Solve it. Your b is a -1. Put it in function form. You have 9x minus 1. So when you look at f of 15 and substitute it in, you see f of 15, and we'll give you 134. When you set this right here, 9x minus 1 equals to 53, and solve it, you see that x is 6. Write it as an ordered pair, and you get 6 and 53. Now, let's look at the next set of points, or the next part. 5 through 7, you're going to determine whether the table represents a linear function. If it is linear, you're going to write the function below. If it is not a linear function, you're not going to write, you will write not function. So I've already worked the first one for you. Now, the first one on this, you're going to have to look at this right here, and you're going to take so what you're going to do, the first thing you're going to do is find the slope, and yes, you will have to check every single one of these points. The other ones we already knew it was linear, so we did not have to check every point. So when I look at this right here and put it in slope, use the slope formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, then you're going to put each one of these points, and so you see I have these color coded: 11 over 5, 7 over 3, and start off with 7 over 3, minus 1 over 0, and then you're going to work 1 over 0 minus a -9 over a -5. And when you put each one of these in into the calculator, it does not take long to put in the calculator. So you're going to go to, when you put this in, let's clear this off. I'm going to turn it off. Sometimes it's easier to turn it off, and then, so I'm going to go to second 0 and second 0, turn it off and turn it back on, and then I'm going to clear it. So when I look at this right here, I'm going to have to put each one of these points in to check to see if it has the same slope. Now, when I look at this right here, I'm going to go to alpha y equals, hit enter, and I'm going to put in 11 minus 7 over 5 minus 3. As a slope of 2, I'm going to go to alpha y equals. I'm going to check the next one. I'm going to put 7 minus 1 and 3 minus 0. And you see I get 2. Now, do not stop here. You still have to check all the points. So when I look at this next one, I have 1 minus 0 over, let me start again, alpha y equals, and then you have 1 minus -9 over 0 minus -5, and then when I look at this right here, I see that I have the same slope all the way up and down. So now I know it is a linear function. So you can look at this and say, yes, this is a linear function. And why? Because it has the same common difference, which is the slope. Now I'm going to use any set of points that you want to in order to substitute it back into slope-intercept form to come up with the b. Now I'm going to use 0 and 1 because 1 is positive and also 0, and I know that anything times 0 is 0. And my slope is 2, so when I substitute this in, right here, y, m, and x, substitute those out, I see that my b is 1. Now I'm going to write it in function form. So f of x equals my 2, which is your slope, x plus 1, which is your y-intercept. Now, I want you to work 6. I want you to work 6 just like you did number 5 right here. I'm going to leave it on number 5 so you can use this as an example. So pause me while you work number 6. Now let's look at number 6. On number 6, when we look at that, the first thing that you have to do is find the slope. So you have to check every single one of these points, and like I said before, it does not take you long to check it just like this. I've already have this written out for you, but you can check it very quickly on your calculator. This is from problem number 5. So I am not going, so just put this in the calculator, and when you did put it in the calculator, you see that the common difference is 3. So right away, you know, yes, this is a function. Why? Because it has the same common difference, which is also your slope. Now, I'm going to use any set of points and my slope to put it in slope-intercept form right here. I use the points 4 and 13, and like I said, you can use any sets, it doesn't matter. And I substitute out the y, m, and x, and when I do, I come up and my b is 1. Now I'm going to write this in function form. So when I write this right here, I see that I have f of x equals, here's my slope, my y-intercept, so I have 3x plus 1. This is your answer. This is what you're looking for. Now look at problem number 7. On problem number 7, you're going to do the same thing. You're going to have to check to see if it has the same common difference right here. If it does not have the same common difference, then you would put no, it is not a linear function. And why? Because it does not have the same common difference or slope. If it does not have the same common difference, then once you find that out, you can stop. You do not have to go through this other part right here. But it must have the same common difference, and you must check every single point all the way up and down. So put me on pause right here while you work number 7 just like you did number 6. Pause me now. Now let's look at number 7. On number 7, when I work number 7, you see that we started off the first 2 points right here when we started checking them are 7. However, when you got to the third point right here, the slope is 8. So this is why you have to check all the way up and down. Notice once we get a slope that is different, we stop. We do not have to do all of this other part right here because it is not a linear function. We're not going to work out any of this because there's no way we can come up with a function right here when it is not linear. So a function, if it does not have the same common difference right here, and you see it's 7, 7, 8, so we say no, it is not a linear function. Why? It does not have the same common difference or slope. Now, so make sure that all of these have to be the same before you're able to do all this other work right here.